So how do you actually talk to a machine? I mean, really tell it what to do? For decades, the answer's been lines and lines of pretty complicated code. But what if you could do it all in just a few characters? Seriously, what if a language existed that was so simple and AI could write it as easily as you and I write a sentence? It sounds kind of like science fiction, right? Well, a new language is doing just that. And trust me, the difference is wow. It's staggering.
Okay, just take a look at this. On the left, that's your standard Python script for a super simple task, making an LED light blink 10 times. And yeah, it works perfectly fine, but you can see it takes a whole bunch of lines to get it done. Now look at the right. That single line? That's the entire instruction in a language called VLOGIC. 16 characters. That's it, to do the exact same thing.
So, that's the big question, right? How on earth can so few characters do so much? How is that even possible? Well, that's exactly what we're going to unpack right now. To figure that out, we have to get to know the language itself. Let's dive in and meet VLOGIC. Okay, so VLOGIC is what they call a super short programming language. It was designed by a company named Viet Systems for a really specific reason. They wanted to create the perfect language for controlling the physical world. You know, things like robots, all our smart home gadgets, factory automation, and here's the kicker, especially when an AI is calling the shots.
And when they were building it, they had 3 big goals in mind. First up, standardization. Let's be honest, the whole Internet of Things world is kind of a mess, with all these different devices speaking different languages. VLOGIC wants to be that universal translator. Second, and this one is absolutely crucial, it's built to be AI-friendly. The whole structure is so simple and logical that an AI like ChatGPT can take a normal sentence from you like, hey, blink that light 10 times, and just spit out the perfect VLOGIC command, no problem. And third, pure efficiency. Shorter commands mean faster communication. And when you're controlling robots in real time, every millisecond counts.
So, how does it pull off this incredible trick of being so short? Well, it all comes down to a few core building blocks. Let's start taking them apart, one by one. All right, the most basic piece of the puzzle is something called an action. The easiest way to think about these is like the verbs of the language. They're the simple, direct commands that tell a device, do this.
And the logic here is just refreshingly simple. D1 just means on. That's it. O2 is the code for a specific device, like light number 2. So you put them together, D1, O2, and it literally just means turn on device 2. Makes sense, right? Want to turn something off? Well, that's D2. So D20101 means turn off device 101, which in this case is an LCD screen. It's so direct, there's no confusion.
But you know, just turning things on and off, that's not very smart, is it? To add some real intelligence, you need conditions. This is where we get into the classic, if this happens, then do that kind of logic. This is how the system actually starts making decisions on its own. And the way it's written is it's really elegant. You just put the question, the thing you want to check, and side square brackets. Then, right after it, you have 2 sets of parentheses. The first pair holds the action for if it's true, and the second pair holds the action for if it's false. Simple as that.
And this shows you exactly how it works in the real world. Let's look at that first one, I133. Okay, that's just the code for the water temperature sensor. So the part in the square brackets, I133 greater than 25, is literally asking the question, is the water temp over 25 degrees? If the answer is yes, it does the first thing in parentheses, D102, which turns on light 2. If the answer is no, it jumps to the second set and does D103, turning on light 3. See? You can encode complex, real-world rules in just a few characters.
Okay, so we've got actions and we've got decisions. The last big piece we need is a way to do things over and over and over again. And for that, VLOGIC uses loops.
And look at that, we're right back where we started, at that very first puzzle. That command, L10 of D1, O2, W1, D2, O2, W1, should make total sense now. L10 means loop this 10 times. And what are we looping? Everything inside those parentheses. D1, O2, turn light 2 on. W1, wait 1 second. D2, O2, turn light 2 off. And W1 again, wait another second. It's simple, it's powerful, and it is incredibly compact.
So there you have it. Actions, conditions, and loops. Those are our basic building blocks. Now let's see what happens when we start snapping them together, kind of like Legos, to build something really smart.
Because this is where the real magic happens. The true power of logic, just like with any programming language, isn't just in the individual pieces. It's in how you can combine them, how you can nest them inside each other to create these amazing, complex chains of logic.
Let's actually build a complex command together, step by step. Imagine we're running a smart greenhouse. Okay, step 1, we check the humidity. That's I10 less than 50. Now, if that's true, if the humidity is low, we don't just do a simple action. Instead, watch this. We're going to stick another entire condition right inside the if true part. This new one checks the temperature. So now the logic is, if the humidity is low, then check the temperature. And if the temperature is high, turn on light 4. But if the humidity is low and the temperature is not high, do something else entirely. And of course, if that very first humidity check was false to begin with, we have a totally separate action for that. I mean, look at that. One single line of code is now running a complex, multi-step climate control program. That's just wild.
Okay, this is all really cool in theory, but you're probably wondering, where is this stuff actually being used in the real world?
Well, its applications are popping up exactly where you'd think. We're talking smart factories, using it to control entire assembly lines. We're talking smart homes, where it can manage your lights and your thermostat based on what the sensors are reading. It's being used to program robots. And this is a big one. It's being used as that critical link, the go-between for AI agents like ChatGPT. It lets them take our normal sentences and turn them into direct control over physical hardware.
But I think my favorite example, the one that's just the coolest and easiest to grasp, is this one. Check this out. That single line of VLOGIC you see, that is a complete recipe for an automated drink mixer to make a strawberry tea. Seriously, N4 is the command to start the Make Drink program. That first set of numbers, those are the ingredients, which pump to use for each one. And the second set of numbers, that's the exact amount of each ingredient, down to the milliliter. A complex, physical task boiled down to one simple, elegant command.
So when you boil it all down, here's the most important thing to remember. VLOGIC isn't just another programming language. It's really designed to be a bridge. It's a bridge that connects the way we think and talk, and now the way our AIs think and talk, to the direct, simple actions that machines actually understand.
What it does is simplify that communication down to its absolute core. It makes controlling incredibly complex systems easier, faster, and just native to AI. And that really leaves us with a pretty fascinating question to think about, doesn't it? As that line between our digital world and our physical world gets blurrier and blurrier, could a super short, super logical language like this actually be the future of how all of us, humans and our AIs, talk to the world of machines all around us?